dynamic, and it's a function of angle of attack and G. What we're going to be talking about is managing G load to make the ailerons more effective. With less G on the airplane, the ailerons are more effective and the roll rate is faster. With more G on the airplane has a slower roll rate. Less G, faster roll rate, more G, slower roll rate. Okay. So the conventional thinking is when you turn the airplane, and we've got way too much speed to be doing this, so let me slow it down. The conventional thinking is when you're in a 60-degree bank turn, you have 2G on the airplane and you're approaching stall. So there's 45 degrees of bank, and if I hold the altitude, you can see the stall tape coming up now. See the red stall tape coming up?
Yeah, I can see.
And so we're getting into a loaded situation, and most pilots, when they're here to recover from here, they want to go like this. And look how slowly the airplane's coming around.
Okay. Because
you've got a big load on the airplane. Now let me get into that area again where we're close to the stall. And watch the speed tape when I unload. Boom. See, it disappeared.
And the roll is
and the roll was so much faster. Look how fast the airplane rolls compared to when it's unloaded when compared to when it's loaded. So the point of that exercise is you want to unload to make the ailerons effective. And so when you get into extreme unusual attitudes, what you want to do is fix your G first, go from 1G to half a G. That way you're still keeping the carts and the flight attendants and the passengers in their seats. You're not at 1G, you're at half a G.
Oh,
and at 0G, they might start floating back there, right? So if you can lower it from 1G to half a G, your ailerons will be more effective to roll the airplane from whatever attitude it's in. This way, so we can see Earth. It's a better contrast than the ocean to the sky. And I need about 230 knots to enter this maneuver. And we'll go left because that's where most of the green stuff is. There's 230 knots more or less, so I'm going to pull and roll to 125 degrees. I'm going to let the nose fall, and I'm going to freeze. There have been about 22 airliners in the accident database that have shown up in this space right here. Okay. Inverted and nose low. Wake turbulence, instrument malfunction, the pilot followed an inappropriate attitude indicator that was rolling over, so he just followed it and got himself over here. Big vortex off of a mountain, United 585 ended up here. Bad place to be, right?
Yeah.
So the process, like I said earlier, is unload. So you're here.
Yeah.
If you pull right now, what's the airplane going to do? All you're going to do is accelerate your way into Earth.
Yeah.
So what I need you to do is push, and these are serial steps. You do them one at a time. You don't do them together. And because you're startled, you're going to want to do things quickly, and there's no reason to do it too quickly. What I want you to do is push, roll the airplane with full aileron deflection, and you're going to end up like this. Now things are pretty normal. The nose is just low on the horizon, and the speed would be building really fast, so you start pulling, and you want to pull this off, and you want to pull the speed brake up. To pull the speed brake up, you pull this thing up and back. Okay? And then you get the nose above the horizon, and things will be pretty normal. Now, push, roll, pull aileron. Roll again. Now start pulling. Pull the power off. Pull the speed brake back. Keep pulling. Very well done. Very well done. I have the flight controls. Since we're here at 280 knots, let's see how high I can get the nose to do the nose high recovery. So, see this brown line right here? It's about at the 30-degree mark. From there to 40 is 10. From 40 to 50 is another 10. But from the brown line to the 50 line, where the airplane currently is 20 degrees. Most pilots, when they're startled, look down at that instrument right there, and they think their pitch altitude is 20. See how how they can see how they can think it's 20?
Yeah.
From here, where the brown line is, to here is 10, and another 10 is 20.
Yeah, right.
The shadow is here.
So when you look outside, can you tell if that's 20, 30, 40, or 50 by looking straight outside?
There's no reference.
I had to look to my side.
You must have some aerobatic experience, because that's an aerobatic skilled pilot that knows to look out the side window. Now, when you look out the side window, is that scary?
Yeah.
On a jet airliner.
Yes.
Now look at where your speed tape is. You're almost stalled.
Yeah.
So when you unload and you push, your the speed tape should disappear. But you're at 180. You're at 180 tons. Flaps up. The stall speed of this airplane typically is like 190 knots. Flaps up at 180 tons. But when you push and lower the G, that speed tape is going to disappear. And that's when you know you've pushed enough, is when that speed tape disappears. Now, the recovery from here, according to the Boeing manual, and it's perfectly okay, is just to hold half a G by pushing it that much and continuing to hold that much, and the nose is going to drop at 3 degrees per second until it gets to the horizon, right? And that's fine. Another technique is to push and to roll it 45 to 60 degrees. And you're going to be doing this a little bit to get to 45 or 60 degrees. That'll be a little faster. There is some benefit of doing that. And as the nose slices through the horizon, level the wings again. Okay?
Okay.
One more point. So the engines in this airplane are underneath the wings. So when you add a lot of thrust to these engines, what happens to the nose?
Right now?
That's exactly what happened to Fly Dubai. They flew 4.5 hours. They made a missed approach. They made a missed approach. They held for 2 hours. They made another missed approach with only 55 passengers in the back of the airplane, and they'd flown for over 6 hours. They hit the toga button. The engines went to 101%, and the airplane went.
Whoa.
And instead of unloading like this, they unloaded like that because they were startled. And the airplane went from, I have a model, and the airplane went from here to here.
Like a pump.
Because they didn't unload to half a G. They didn't know to look for this speed tape to disappear to know they've unloaded enough. Okay? So what's your so the point is since the thrust is making the nose pitch up, once the speed tape disappears, you could consider pulling this back to help you get the nose to fall. But if the nose is already falling at 3 degrees per second in your estimation of looking at the instrument, there's no reason to necessarily pull that back.
Okay.
So what's your preference? Do you want to recover straight ahead, or do you want to recover with 45 to 60 degrees. It doesn't matter. It's either technique is okay.
I think it's
Just so we-
maybe just push
Okay,
down.
just
Yeah.
push.
Maybe.
So you're going to push about this much, and you're going to watch for the speed tape to disappear. You're going to watch the attitude indicator. If it starts moving 3 degrees per second nose down, you don't have to do anything with this. But if you want to, you can pull it back to help the nose come down. Okay?
You see it's not enough, maybe you just help a little bit with that.
If the nose is not moving enough, if this didn't disappear, then you need to control that with this by
Okay.
pushing more to get this to disappear. You're unloading or removing G from the airplane by pushing on this. So you know you've pushed enough on this when this disappears.
Yeah.
Yes.
Yeah, makes
Okay.
sense.
Okay? You have the flight controls.
Okay.
3,
Back control.
2, 1, release. Push until it disappears. There you go. Don't pull back yet. Don't pull back yet. You're at 130. As soon as you start adding load to it, it'll stall. Okay, now hold that. 10 degrees nose down. Hold that, hold that. That's the pitch limit indicator. Perfect. That was a little secondary stall. There you go. Maneuver complete, and you have recovered.
Okay.
Awesome.
Does someone else want to get in the seat?